Hi all, we are starting lecture 15 on Intro to Geometry. And so geometry tends to be based very much on the definition of a lot of objects. And some of the initial objects can be pretty tricky to identify. And so let's run through some basic definitions. First of all, for a point is a location in space. Just some location in space. We mark it with a dot and we identify it by a capital letter. Okay, so point A. A line segment consists of 2 points and all the points between those 2 points. A lot of people like to talk about things being straight, but really we just need a point A, a point B, and all of the points directly between them. Okay, and so this is line segment AB. Let me do that correctly. This is line segment AB with a little line above it. Okay, so that would be a line segment. A line is a line segment that extends infinitely in both directions. Right? We want it to go on forever, even if we don't draw it that way. So a line segment that extends infinitely in both directions. So I'm going to have a point A and B, and I'm going to connect them. But to create the line, I'm then going to keep going infinitely in opposite both directions. And this is line AB. Okay, we can also label lines with a cursive L, a lowercase letter, like a lowercase L. Okay, so that's a line. A ray is then two line, oh, sorry. I was going to give you angle. A ray is a line segment that extends infinitely in one direction. So I would have 2 points, form my line segment AB, and then I'm going to extend infinitely, but only in one direction. The other end is an endpoint. So this is going to be ray AB, and we always start at the endpoint and go towards the point that we're going to infinity. An angle then consists of 2 rays that share the same endpoint. So that means ray AB and ray AC share the endpoint A, and together they are an angle. And so when we measure it, we measure this distance in here, typically in degrees. And then a polygon is a simple closed curve. And actually, I'm not even sure that we define it to be simple. So let's just go with a closed curve, right? That consists, my spelling's a little off today, sorry y'all, only of line segments. Okay. Closed just means that it has to end where it starts. So something that is closed, like a figure 8 would be closed. A circle is closed. A rectangle is closed. Something that is open, a curlicue, an S, something that looks like this, right? Those things are open. So something that is closed ends where it began. It can intersect itself. It doesn't have to. The word simple and non-simple, or simple and complex, references whether it crosses over itself or not. So this one would be not simple or complex, whereas these would be simple closed curves. Okay, because they don't intersect each other. Okay. And so when we go to start classifying our polygons, we classify it by the number of sides that it has. So it has 3 sides, you have a triangle. 4 sides is a quadrilateral. 5 is, why am I blanking on that? A pentagon, sorry. All I could think of is quintuplets. 6 would be a hexagon. 7 is a heptagon. 8 is your standard octagon. 9 is a nonagon. 10 is a decagon. 11 we don't have a special word for, so that's just an 11-gon, right? And 12 is a dodecagon. Do meaning 2, dec meaning 10. 20 is just going to be a 20-gon, as is any other number that's not special. So that's just an n-gon. Okay. And I'm a little off with my position. Let me move them over for you. There we go. Okay. Now that we know what to call them based on their number of sides, we want to talk about whether they are convex or concave. So concave is something that looks caved in. So something like this, let me start drawing, would be concave, whereas this one would be convex. Okay. Let's see. Something like that is concave. Okay, and something that's concave means that there are that if you draw a line, there are 2 vertices. And vertices, by the way, are just your points, for which the diagonal between them and that just means the connecting line. So the line from this one to this one lies outside the figure. If you can draw one of those, that means that you have a concave figure. Okay, so here I could draw it from here to here. That diagonal lies outside the figure. It doesn't have to lie completely outside the figure. It just has to go outside for a little bit. Okay, however, over here, for a convex figure, any diagonal lies completely within the figure. So if I connect any 2 points, that's going to be completely inside my figure. Okay. All right, and then the other video is going to pick up here.